All right, so we here are going to do number 6. You decide which formula, which one of these choices is going to give me the correct answer for the area bounded O, and then rotate around by the curves, and rotate around the line y equals k. So to do that, the volume of the area rotated the curve rotated around the line y equals k. So the first thing I have to do is figure out what I've got going on here. Do I have a hole? So I look over here, and I notice that when this shape rotates around this axis here, okay, there's going to be a big old gap right in this area right here, right? This area here is going to be gone, so I'm going to have a hole, which means in general I'm going to have pi integral the big radius minus squared minus the little radius squared dx. Now, why did I choose dx? Because I'm walking this way through my circles. My circles are rotating this way, so I'm walking through my circles this way, which sets my bounds from A to C, because that's my x coordinates for my starting point and my ending point. Now, I have to define what my big radius is. My big radius is from here all the way down here. Now, we learned a quick trick for that. We don't actually figure this out from scratch. We could if we wanted to, and that is my values of h, so h of x, minus the line I'm going around, which is k squared, minus, and then the little radius is going to be my inside radius here, right? Because it's going to be smaller of the two when you go around this line right here, right? It's closer to it, so it makes a smaller volume. Minus, and then it's going to be g of x minus k squared dx. Now, if you're on the advanced course, you might be thinking, Mr. Resny, actually you've got this wrong, because it should be this k value minus h, right? Because that would be the positive value. But remember, this thing is squared, so we don't have to even think about it anymore. Just whatever we rotate around, we just put a minus, whatever it is, and we throw it there, okay? This would be the volume of the outside rotated around the line. This would be the volume of the inside rotated around the line. And then the outside minus the inside would be the volume of the shape we'd make. All right? All right, so now I'm going to do the other problem. That was problem number 6. Now I'm going to do 8a. All right, for 8a, we're looking at a region R in the first quadrant. There's enclosed in a hyperbola. Hyperbola. There's a reason why I taught that to you last year. Around the x-axis and the line x equals 5. So theoretically, you should know, oh, okay, well, I know how hyperbola is. It's x squared minus y squared, so it must be one of these ones that opens left, right. Now you might be thinking, Mr. Resny, I don't remember that. Well, there's a quick way you could figure this out. You could throw, say, a 3 in here. You would get a 0 for y to make a 9. You could throw a 4 in there. That would be 16 minus y squared equals 9. So 16, if you throw a 4 in there. Then you subtract that across. I get negative y squared equals negative 7. Y equals plus or minus the square root of 7. Because that's somewhere between 2 and 3. So you put a dash between 2 and 3. And then it's plus or minus. So you put a dash down here and go, oh, it's one of these. It goes like this. Correct? And it says the region in the first quadrant. So we're not going to worry about this at all. Then it says enclosed by the x-axis, so this is part of my line. So this is a shady part, this is a shady part, and x equals 5, and x equals 5 is this shape right here. So we end up with this shape right here, where this is 5, and then 5, comma 0. This point up here is going to end up being 5, comma whatever makes this work. So I plug a 5 in, and I get 25 minus y squared equals 9. I get negative y squared equals negative 16. It takes no imagination at all to realize this point here has to be 4. And this point here, as we discussed by guess and check, was 3, 0, although you could check it by plugging in a 3. Or plugging in a 0 for y and seeing what x needs to be when it runs in that line. Regardless, you should be able to get these points to this point. Hopefully, you remember what a parabola is well enough that you could actually guess and check which parabola it happens to be. Okay, so now I want to rotate this around the x-axis. So we know how to rotate things around the x-axis. We're going to rotate it this way around the axis, which means I'm going in the x direction, which means I need a y equals equation so I can write it in terms of x, right? Because my radius is going to be how far I am in the y direction. So what's the equation in terms of y? Well, I get negative y squared equals 9 minus x squared. I get y squared equals x squared minus 9 square root plus or minus, but I can ignore the plus or minus because I'm only doing this top shape up here, so I'm just positive. Okay. Now I'm going to write this in the way we like to in calculus because we know roots are evil. Yes. All right, now we move forward and we're going to go, okay, we're going to rotate around this way. We're going to start, I'm going to go pi integral. Where am I starting my walking through? I'm starting at 3. So I put a 3 here. I'm ending at 5. Boom. That's a 5 right there. What's my radius? My radius formula is x squared minus 9 to the 1/2. That whole thing, the radius we square, dx. The rest should be basic calculus, although that's the part I was most worried about. So let's see if I get the same answer just for the fun of it. If you're good, go ahead and turn this off because I'm doing nothing other than spend the rest of the time solving this thing. But I was concerned that I got the wrong answer, so let me try this just one more time just to be sure. Square root squared isn't that convenient. Wasn't that nice of them? All right, and raise power by 1. Divide by the power I get. Raise power by 1, divide by the power I get, from 3 to 5 pi. Plug in 5, get 5, 1, 20, 25, 1, 25 over 3, minus 45, minus, plug in a 3, I get 9, minus 27. All right. Minus 27. So then I do a little mathage. Let's hope for the best. Okay, unfortunately I got everything divisible by 3. That's just awful. Let me cheat. Just make this 41 2/3 minus 45. Minus negative 18. And then here I'm going to get negative 3 1/3. Here I get plus 18. It seems as awful as whatever I got on the other thing, 14 2/3. And I still need to remember my pi. Boom, baby. There it is. All right, so that's my approach. Okay, so that should have been okay. Hardest part is to remember, there's a reason why this was on a quiz, is because hyperbola. Oh yeah, hyperbola. Hyperbola. But you can guess and check a shape, and if you know what a hyperbola is, you could guess and check your way to what the shape looks like and pull that off. All right, hopefully that's enough. If it isn't, send me some more information. Maybe we'll Zoom it or something. Okay, bye.